we are given cotangent theta is 1 and theta is acute. So we need to determine tangent theta, cosine theta, sine theta, cosecant theta, secant theta. Theta is acute, that means we are in quadrant 1. So all the values, other functions we have will be positive. So I'm taking a reference triangle, which is a right triangle. The opposite is O, hypotenuse is H, and the adjacent is A. Now, if you remember tangent and cotangent relation, since tangent theta and cotangent theta are reciprocal, so then cotangent theta 1, meaning is tan theta is also 1. So we start from tan theta. So as we know, tan theta is O over A. So it is 1. That means O is 1 and A is also 1. If O is 1, A is 1, you can use the Pythagorean. H squared equals A squared plus O squared. You will see your H is radical 2. So we got H equals radical 2. Now sine theta, we know it is coming from so, cosine theta is coming from ka, and tan already we have. So then sine theta will be O over H. O is 1 and H is radical 2. So it is 1 over square root of 2. And the cosecant is reciprocal of sine, so it will be just radical 2. You just flip it. Cosine theta will be A over H, which is 1 over square root of 2. And then we have further secant theta, which is reciprocal of cosine, that means radical 2. Example 2, we have cotangent theta is negative 5 over 7 and sine theta is positive. So we need to know where we have sine theta positive. If you look at the quadrant, you know sine theta positive here and here. Since cotangent theta is negative, so it must be in the second quadrant. So we are in the second quadrant. So since cotangent theta is negative 5 over 7, so tangent theta will be negative 7 over 5. Now we need to complete our triangle. So we know tangent is O over A. So O is 7 and A is 5. So I'm using reference triangle, so I ignore the negative sign. So determine H. So if you have 7 and 5 here, then H will be, using the Pythagorean, you have H squared equals A squared plus O squared. So you see that H will be, so A is 5, is 25, square it, and then O is 7, square will be 49. So you are getting H is equals square root of 74. So we got square root of 74. That is our H. Now we are looking for sine theta, and we said sine theta is positive, and we are in second quadrant. So our sine theta will be 7 over square root of 74. So then reciprocal cosecant theta will be square root of 74 over 7. Example 3, we are given secant theta is negative 11 over 6 and theta is in quadrant 3. So the location of terminal site is here in quadrant 3. So we know in quadrant 3 tangent will be positive and cotangent will be positive. All other will be negative. Okay, so just remember tangent is positive, cotangent is positive because in quadrant 3. Since we have secant theta is negative 11 over 6, cosine will be reciprocal, which is 6 over 11. And now we know it is cosine, so the adjacent is 6 and the hypotenuse is 11. So we need to find our opposite. So we know H squared is O squared plus A squared, which is the Pythagorean. So H is 11. When you square it, it will be 121. Opposite we need to figure out. And this is 36. So now simplify and find your O. So we get opposite is square root of 85. Now sine theta is O over H. So then it will be square root of 85 over 11, and it is negative, so put a negative in front. Then cosecant will be just opposite, reciprocal, so it's 11 over square root of 85. Now tangent is O over A, which is square root of 85 over 6, and that one will be other way, 6 square root of 85. So that's simple. Now you know tangent and cotangent, they are reciprocal, the answer must be 1, but you can plug your answers and simplify, you will see that it is 1. Now secant theta we have negative 11 over 6, and cotangent theta we have found 6 over square root of 85. So if 6 you cancel out and you get negative 11 over square root of 85. So negative 11 over square root of 85, this is exactly cosecant theta. So you can verify why it is cosecant theta easily. Now last one is sin squared theta plus cosine squared theta. For all values of theta we know it is 1, but if we plug the values from sine, square it, and then add with the square of this one, you will see that your answer will come out as 1. So these are basically the understanding, but I want to show you why we have got secant theta, cotangent theta equals actually our cosecant value here. This is not difficult to see. So first you see secant theta is 1 over cosine theta, and cotangent is cosine theta over sine theta. Cosine cancelled out, you get 1 over sine theta, which is cosecant theta, and that's why the answer came out like negative 11 over square root of 85. All right, so these are some verifications, especially from this part, I should say, from D. All right, we are done.